All right, so in this video, we're going to go over the cooling system and how it works and how to diagnose most of its problems. All right, so this is a chart with all the, it's a flow chart with all the, what's it called, components. So we'll go over them one by one. So we start here with the coolant reservoir. So this is where you would add your coolant to start filling up your system. So the blue lines are going to be cold coolant, and then the red lines are going to be hot coolant circulating through the system. So cold coolant will come here, and then it's going to start at the thermostat housing. So this is where the party starts. You can see there's a lot of lines going in it and then going out of it. So when it gets to the thermostat housing, it's going to be blocked by the thermostat. So the thermostat is going to stay closed until the engine over here gets warm enough, and that's when we call reaching operating temperature. So we don't want the coolant to start cooling the engine just yet. We just want the engine to get warm enough so it could start its normal cycles at operating temperature. So that's what the thermostat is job. It's to make sure the engine reaches operating temperature. So it's going to stay closed. And then eventually when the computer over here, it's going to give a signal. It's going to get the signal from this guy, the coolant temperature sensor. So here. And then when the coolant is at the desired temperature, the thermostat is going to start opening, and then the flow of coolant will start. So it's going to start down here, and then so it's going to find its way in the radiator. So it's already going to be hot from sitting in the thermostat housing because this thermostat housing is going to be right near the engine. So it's actually going to be bolted on the engine. So the cold coolant that comes from the reservoir will start heating up in the housing, and then it's going to start moving up here. So this is the upper radiator hose. Okay, and then it's going to start moving in the upper radiator hose into the radiator over here, and then it's going to start cooling. Okay, so there's another coolant temperature sensor here and radiator fans here. So I listed them in blue. So that's sensors or anything that communicates with the computer. So there's another sensor here just to communicate with this sensor here, to tell the computer in difference of temperature. So that difference of temperature is going to it's just for a specific code to diagnose this guy over here, a bad thermostat. So some cars will have that and some cars won't, but that's the main reason. It's to tell the temperature difference to diagnose a bad thermostat. And then I already had a scenario like that once. I don't remember the code, but that's basically the gist of it, of why we have two temperature sensors here. So the hot coolant will find its way in the radiator over here, and then it's gonna start cooling down from either the radiator fans or from driving down the road. So that's why you have your grill open, the front bumper of your the grill on the front bumper. The cold air is going to start hitting the radiator, and then it's going to cool down this hot coolant. So now we have cold coolant coming out now, and then it's going to find its way into the water pump. So this is going to be a lower hose, so lower radiator hose, this guy over here. And then the water pump is the job of the water pump is going to be to distribute cold coolant across any component that needs it. So depending on the car, it's going to go to an oil cooler, a turbocharger if it's equipped, and most importantly, it's going to go to the engine. And that's the main component that we're trying to cool. So here we have the cylinder head and the engine block. So the coolant's going to circulate around that to cool it off. And then when it's taken enough heat from the engine, it's going to come back and find its way in the thermostat housing again. So same thing with the oil cooler. So the cold coolant will go here, draw the heat from the oil, and then find its way back to the thermostat housing, as well as the turbocharger if it's equipped. So cold coolant will come over here and then cool down the turbo, and then find its way again, hot coolant will come back to the thermostat housing so that the cycle could start again. And then we also have one guy over here, which is the throttle body, and then there's actually hot coolant that comes out of the thermostat housing to the throttle body to cool down the air a bit. So if you live in colder climates, and if you have air rushing in the throttle body, sometimes it could cause some small, it's called icing, so small ice particles around the throttle plate, and that could disturb the airflow inside the engine. So that's why most car manufacturers now, they run a coolant hose from the thermostat housing all the way up to the throttle body, just to warm it up just a bit so they won't get that effect. It's similar to having air tools that if you've ever used air tools, the air that's rushing into it makes the tool really cold. So that's the same concept. If there's lots of air rushing into it, and especially on a cold day, then it could create ice and then disturb the flow of air. So, and then the cold air find its way, the cold air find its way back into either the thermostat housing or the coolant reservoir. I just put it in the coolant reservoir because that's the card that I was looking at. So that's the setup here. And then when it reaches the coolant reservoir, the cycle continues again. Okay, and then we have one more guy over here, which is the heater core. So these don't have a cold coolant going to them. So we need hot coolant going to the heater core, because this is where you're going to get heat from your engine. You're going to get heat inside the cabin during the winter months. So the hot coolant will come in, and then the fan is going to blow on here. And then that's where you get your hot coolant inside the car over here. And then the hot coolant comes back out and restarts the cycle. So this hot coolant is just probably a few degrees lower than the one coming in, but it shouldn't be it shouldn't have a big difference in temperature, because this is a scenario where we really need a hot coolant so that we could get heat inside the cabin. All right, so that's the main flow of coolant inside any engine or any engine bay. So depending on the car make and model, they'll have different setup. Some car manufacturers will run coolant hoses wherever they please, so either to various components, and but this is the main idea of the cold coolant going in and then the hot coolant coming out. So the main factors in any cooling system is going to be coolant level, coolant flow, and then coolant heat dissipation, which is the ability of the coolant to get rid of its own heat. And any disturbances in any of these is going to cause problems, and then it's going to cause the most common customer complaints, which is overheating conditions, and the second one, which is a no heat in the cabin. That's the most common complaints. And also there's another complaint, but it's leak, but we'll go over that after this. So coolant level, whatever disturbs the coolant level is going to be leaks. So leaks in any of these hoses here, leaks in the oil cooler, leaks in the radiator, water pump, turbocharging cooling lines, and any leaks in there will make the level drop, and that's where you'll get a overheating condition, since you don't have enough coolant to cool down all the components that are listed here. Okay, and then so that a big enough leak will cause a overheating condition if it's not addressed correctly. So if you have a leak, most of the time you could see it on your driveway or underneath your car. It's going to leak and leave a puddle. So the worst case scenario is going to be this guy over here. This is a head gasket. So it's the head gasket is the gasket between the cylinder head and the engine block. And that if that leaks or if that fails, then coolant will leak inside the combustion chamber, and you will have a severe overheating issue. But you won't see any fluid inside or around your car, since it's all getting burnt up inside the engine, and that's the worst case scenario. So you'll have to either it's a engine overhaul or just a replacement of the head gasket. But most of the time it's going to be new head studs, a new gasket, resurfacing of the head if you drove it and you did enough damage with a overheating condition. All right, next up is going to be coolant flow. So whatever disturbs the coolant flow is going to cause a overheating condition once again. So who's responsible for coolant flow is going to be this guy over here, the water pump, and this guy over here, the thermostat. So if the fins on the water pump are broken, that's something a bit more rare that could happen, but it does happen. Then there's nothing that's going to be pumping the cold coolant around the system, and that's when you're going to get an overheating condition. As well as this guy over here, the thermostat. So if this guy is stuck closed, then we want it stuck closed only until the engine reaches operating temperature. But if it's constantly closed, then there's nothing stopping the temperature from going up, and that's where a disturbance in the flow will cause another overheating condition. All right, and then lastly, it's going to be coolant heat dissipation. So that's the ability of the coolant to get rid of its own heat. So it's basically this guy over here, the radiator. So if it's a clogged radiator, or sometimes there's debris in front of the radiator if you're driving a lot of highway, leaves or dead bugs that are disturbing the airflow from the front of the grill, and then the coolant cannot cool itself, and then that's where you'll get, once again, another overheating condition. And then also heat dissipation, this guy over here, if your radiator fans are not working, then you will get in another overheating condition due to coolant heat dissipation. So these are going to be only on only a few scenarios where this would happen. So if you notice that you're only overheating at red lights, that's because when you come to a stop, so there's no more airflow hitting the front of the radiator. So this is where the radiator fans kick on. So when you're at a red light or stopping at a stop sign, you should hear your fans coming on. So if they are faulty, then usually they'll throw a code to the computer, or usually at a stop sign or a red light, you're gonna start overheating, and then so it can only happen at red lights or stop signs if you have a faulty radiator fans. Because if you drive on the highway or a city and then just regular driving and you don't have that overheating condition, then this guy is your issue. All right, so and then after that, the second complaint, which is going to be a no heat in the cabin. So it's mostly going to come from the heater core, this guy over here. So there's two issues that could happen here. It's a seized or a clogged heater core from either dirt or debris or rust, and then the flow of coolant is kind of stopped from all that from entering the heater core. Like the hot coolant cannot go in, and then when the fan on the inside of the cabin blows air, the hot air cannot find its way in the cabin. So that's one issue where you could have no heat in your cabin. And then the second issue is going to be air bubbles. Okay, so air bubbles could, going back to the original complaint, air bubbles can actually cause overheating condition because air bubbles actually take up space in the cooling system, and space that's reserved for hot coolant. So say you have that big air bubble in the engine block. So everything around that air bubble all the components around that air bubble will not get cooled by the coolant. So that's where it's going to start to overheat. So on most cars, the highest point in the cooling system is going to be the heater core. So air bubbles will always find its way in the heater core. So if you have a big air bubble in the system and it finds its way in the heater core, then you will get no heat in the cabin because the heater core is taking up, once again, it's taking up the space inside the heater core, which is space reserved for hot coolant. And that's how you won't get no heat in the cabin. And yeah, that's pretty much it. So air bubbles causing overheating condition. And yeah, so we had a scenario once where it was a massive air bubble on a Kia Telluride 2020, and we had to bleed it for at least an hour just to try to force that air bubble out, because the customer complained of no heat, but only in the rear. So the heat cannot get to the rear passengers. So on bigger SUVs, they'll have a second heater core like this all the way at the back of the vehicle. So they'll have one at the front and then one at the rear with lines going to them. So the air bubble was probably around here or near the second heater core. And that's why he was complaining of no heat at the rear of the car. So what we had to do was probably rev the engine for about 2,000-3,000 RPM. Rev the engine at 2,000-3,000 RPM for about, I don't know how long. It was probably an hour, 2 hours. It was a really long time just to try to force that air bubble out, because it was not coming out. And sometimes we had that problem for a few weeks and a few months actually, where we sent the customer home and then he actually came back for the same issue, saying, you know, I don't have heat once again in the rear of the car. So yeah, that took a really long time to force that big air bubble out. So a big enough air bubble will cause these issues, and yeah, and then will cause that customer complaint as well. So no heat in the cabin. But most of the time, the most common issue is going to be an overheating condition. So as long as we fix the leaks, the flow, or the heat dissipation, then all of these complaints will get fixed most of the time. And yeah, so there's only a few components that are going to cause electrical issues in the cooling system. So the coolant temperature sensor or their radiator fans. So either wiring issue or a sensor issue. So it doesn't get more complicated than that. Some other systems have more electrical components to them. So the diagnostics of wiring issue and communication issues are more in depth than this one. This one we only have just a few sensors to work with, and then the rest is all physical and mechanical components. So that's why the cooling system is a pretty easy system to understand and a pretty easy system to diagnose, as long as you know what you're looking for. And obviously with the right tools to either detect a leak, and then yeah, mostly just detect the leak and then work on the system, removing hoses and all that. All right, so that's going to be it for this video, explaining the cooling system, understanding it, and diagnosing mostly all the same common customer complaints. All right, hope you guys find this video helpful. Hope you guys find it valuable. I'll see you guys in the next one. Take care.